Okay, problem number 4. Done a whole bunch of these before, pretty similar ones. Little picture here. This is a picture of f prime. They got some areas under the curve. They got some points for their point, and they told us that f of 8 is equal to 4. And this is the derivative. First question was, when does f have a local minimum? F has a local minimum whenever f prime is changing from negative to positive. That's always your justification for a minimum point. The derivative is changing from negative to positive. So you look over here, negative to positive, right there. Local minimum x equals 6. Next problem, find the absolute minimum value. So the absolute minimum value is either going to be at that minimum point, 6, or at one of the endpoints. They told us f of 8 was 4. So now I'm just doing area under a curve here to find the value at 6 and the value at 0. So going from 6 to 8, I increase 7 units because of that area under the curve. It's like, this is my rate, so that's my total distance traveled in essence. So that means if I just subtract 7 from that 4, I'm going to find out where I am at 6. And then if I just keep going, same thing, 8 and 3 is 5. So from 0 to here, I had to go 5 units. So now I just got to go back up 5. So I take that number and back up 5, and I get the negative 8. I could have skipped this step, just looking at the areas, but I just wanted you to kind of see what I was doing there. So the minimum value is at 0. It's minimum value of negative 8. Third question said, when is it concave down and increasing? It's concave down whenever the second derivative is negative. The second derivative, this is the first derivative, second derivative are slopes. Negative slopes, negative slopes, positive slopes, positive slopes. So it's got negative slopes from 0 to 1 and 3 to 5. It's increasing whenever the derivative, which is this, is positive, 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 negative, positive. So 0 to 1, 1 to 4, 6 to 8, but not at 1, so be careful with that. It's not going to matter because of this. So it's both from 0 to 1 and then from 3 to 4, combining those two. And then the last question says we have this other function. We're going to call it f of x cubed. We want to find the slope of that at 3, and they give us a little numerical value here. So the derivative of this is just a chain rule of 3 times f of x squared times the derivative of what's inside, which is f prime of x, at 3. So it's 3 times f of 3 squared times f prime of 3. F of 3 they gave us to be negative 5 halves squared. F prime of 3. F prime of 3, remember this is the derivative. This is f prime. F prime of 3 is 4. So 3 times negative 5 halves squared times that 4 is 75.